Hello everyone. In this session, we will be studying about Kraft inequality, or which is otherwise called Kraft-Macmillan inequality. So, from this inequality, we can identify whether we can construct an instantaneous code or not. So, what it says is it is a necessary and a sufficient condition for the existence of an instantaneous code with a word length L1, L2, and L3, so on till LQ. The condition says that summation of I equal to 1 to q of r bar minus li must be less than or equal to 1 in order to satisfy this Kraft inequality, where r is the different number of symbols that will be used in the code, and l is the word length, and q is the number of source symbols that are present. Let's consider an example in order to understand this inequality, Kraft-Macmillan inequality. So this is an example that we'll be considering for our study. So the different four source symbols are S1, S2, S3, and S4. And we'll be considering five different set of codes like F, G, H, I, and J are the names given for the set of codes. So code F, code G, code H, code I, and code J. And the corresponding code words for S1, S2, S3, S4 under various code sets are as shown over here. So first let's consider code F and check whether it satisfies Kraft-Macmillan inequality or Kraft inequality or not. So the condition that has to be satisfied is summation of I equal to 1 to q r bar minus li must be less than or equal to 1. So here there are four symbols. So summation of I equal to 1 to 4. R is, go back to this, different symbols that are used in the code. So come back to this tabular column, identify the different symbols that are used over here. 0 and 1 are the only two symbols that are used in coding here. So the value of R is 2. Alright, so 2 bar minus Li. So we'll be substituting the length of each and every code words over here. So 2 bar, the length of all the code words here is 2. So it will be 2 bar minus 2 into 4. That is nothing but 1. So here the condition that must be satisfied is it must be less than or equal to 1. So here it is equal to 1. So what conclusion we can draw from this is it satisfies the Kraft inequality, and it is also possible to construct an instantaneous code. Okay, so next let's consider code G. Code G. Here also we have four symbols. So I equal to 1 to 4, and two different symbols are used. So 2 bar minus Li. The first code word length is 1. Here all the other codes length is 3. So we'll write 2 bar minus 1 plus 2 bar minus 3 plus 2 bar minus 3 plus 2 bar minus 3. So the value of this is 7 by 8, which is less than 1. The condition that has to be satisfied according to Kraft-Macmillan is it should be less than or equal to 1. Here it is less than 1, which means to say it is satisfying Kraft inequality, and it is also possible to construct an instantaneous code. Similarly, next let's consider code H. The length of first code word is 1, 2, second code word length is 2, third and fourth code word length is 3. So I equal to 1 to 4, 2 bar minus Li. First code word length is 1, so we'll write 2 bar minus 1. Second code word length is 2, so we'll write 2 bar minus 2. Whereas the third and the fourth code word length is 3, so we'll write 2 bar minus 3 plus 2 bar minus 3. And the value of that is 1 by 2 plus 1 by 4 plus 1 by 8, which gives us a value 1. Means to see, the conclusion that we'll be drawing from this is it will satisfy the Kraft-Macmillan inequality, and it is possible to construct an instantaneous code. Next, let's consider this code I. Here we have the length of S1 as 1 and length of S2 and S3 is 3, length of S4 is 2. So let's substitute the values. So I equal to 1 to 4, 2 power minus Li is equal to 2 power minus 1 plus 2 power minus 3 plus 2 power minus 3 plus 2 power minus 2. The value of that will be getting it as 1. It satisfies the Kraftman inequality, no doubt in that. But can we construct an instantaneous code? Go back and observe here. This code word is a prefix of this code word. S4 is a prefix of S3's code word. So we cannot construct an instantaneous code word. So that is the conclusion that we'll be drawing for code I. Next, for code J, go back to this tabular column. First, the code word length is L1, that is 1, L2 is 2, L3 is 3, L4 is again 2. So 2 power minus 1 plus 2 power minus 2 plus 2 power minus 3 plus 2 power minus 2. So after calculating these values, we'll get 9 by 8, which is greater than 1. The condition for Kraft-Macmillan inequality is it should be lesser than or equal to 1. So here we got greater than 1. So the conclusion that we draw from this code J is it does not satisfy the Kraft-Macmillan inequality, and also it is impossible to construct instantaneous code. So this is about Kraft-Macmillan inequality. Here ends module 2. The next session we'll be starting off with module 3. Thank you all.